heavy. Now we are going to learn the other topic, that is refraction by spherical lenses. Here also, here the process is refraction. What is refraction? When a ray of light passing from one medium to another medium, it changes its direction. Sure. So that is, this lens is also works with the same concepts. That is same aspect of this refraction of light. Now, so before getting into that, let us study about the spherical mirrors. Now, what is spherical mirrors? Now, spherical lenses, correct. Okay. Now, what is spherical lenses? Now, there in the spherical mirrors, we studied that a mirror of which, that is, it is a part of a sphere. Okay. Now, the same way, here the lens which is part of a sphere. Now here not a sphere, okay, here the two spheres. Okay, a sphere or two sphere. It may be. Anyhow, there is a spherical surface is there. That is here. Okay, this is the spherical surface. Okay, now how a double convex lens is formed, we will see, or double concave lens is formed. Now, we already, it is a spherical lens means it is formed from sphere. That is, spherical lens means it is formed from sphere. Now, how it is formed? Just to see, we will see. Practically, we will see that. Okay, how it is formed. Now, this is sphere. Fine. This is sphere. Okay. Now, we can say it is the intersection of the two spheres. How it is made? Just to see. Okay, this is sphere. Now I am going to make this sphere here. Okay, fine. Okay, yes, sphere is made. Fine. Yes, sphere is made. Now I am going to take this much part. I am going to cut from here. Okay, this spheres, this much part I cut. Okay, I cut this much part. So I cut this much part. Okay. Now again, this side here, again a sphere. Here, this part I cut. From here, I am going to cut this part. Okay, I am going to cut this part. Okay, now look, from here we cut this part. From here we cut this part. Now the intersection of these two parts. See, okay, so what you form? Look, what is formed here? Here a lens is formed. That means this is the convex part, here it is also a convex. So we can say that this is a convex lens. Like that, a convex lens is there. Now you can see, okay, this is the part of a sphere that is on this side, and this is the part of a sphere which was this here. Okay, so we can say, okay, this lens is formed because of the two spheres. Sure. Now the same way, okay, we can see if this now here the spheres are intersected. Now suppose these two spheres are not intersecting. Okay, this is here and the other is not intersecting. Sure. Okay, then in between this is the part here. Okay, we are going to this part. So here the other sphere is formed. How it is look? The same, the part. Okay, now I am going to make it as like this. Here look. Okay, while here it is, little space must be there in between. Sure. Then, okay, this is, we can say it is a concave lens. Or it is concave lens. This is of here it is, here while it is convex lens. Okay, so here it is of the concave lens and a convex lens. Again the same thing, there also convex mirror. Convex mirror means what we see? Outside what was reflecting, that is of bulged out. Okay, here also convex means bulged out. Okay, concave, cave means inside. So here the concave lens means it is. Now, so here the, okay, we see that, okay, the lens is formed because of the spheres. It is not necessarily be two spheres must be there. Now here, okay, now the one sphere we have taken, okay, and we cut this, and we are only this much part is we are taking. This part we kept like this. This is also a, okay, spherical lens. Okay, this is called the plano-convex because one side is plane, so it is of a plano-convex lens. Like that, the other way, that is, we can say it is like this. Okay, this side here plane, that is convex or plano. Okay, like that also we can see. Okay, so here anyhow one side is of where it is sphere, like that. Okay, one side is concave and the other side is a plane. Now we can say this is of a concave or plano. Otherwise plano convex if it is of one side is of plane and this plano concave. Okay, like that. Okay, these are. Now if both the sides are of convex, then it is called a double convex lens. See, double convex lens. Okay. Now, now that is also there. That is of convexo concave. That is concave or convex. That is also there. Okay, concave or convex. Okay, that is one side will be concave, other side will be convex. That is also there. Okay, now here the double convex. Normally the double convex lens we won't tell it as double convex like that. Okay, we will just say that it is a convex lens. So just a convex lens means you must understand it is a double convex lens. Like that, just a concave lens means you must understand that it is a double convex. Now, while telling about the lens, okay, now you know that what are the uses of the lens. Okay, the lens are widely used in the day-to-day life. You know that it is used, okay, as spectacles. Now you know it is a spectacle. Now what actually then the spectacles means, its lens is there inside. Okay, and other is of a magnifying glass. You know that. Okay, normally we are using to read and all like this. Okay, now what actually this magnifying glass is also a lens, that is a convex lens. Like that, in day-to-day life, everywhere, okay, what we are doing, we are using these lenses. Okay, now some terms which is related to this lens. Okay, now we see that a convex lens or a concave lens is formed by two spheres. Okay, now there in concave mirror, we see that only one sphere was there, so that, okay, it was having only one center was there. That center we called it a center of curvature. Now, here while telling about, okay, now I am going to draw two spheres. Okay. Okay, fine. Without changing it from here. Yes. Look, a lens is formed. So here, this is C1 and this is of C2. Now see, now there are two centers are there, correct? So these are called the centers of curvature. Okay, it is the centers of curvature. Okay, what is the centers of curvature? Okay, while telling about, it is the centers of the circle of which the lens is a part. Sure, these are called the centers of curvatures. Okay, sure, all of you getting centers of, yeah, these of curvature. Okay, so it is the centers of curvature. Sure, all of you? Listen. Here it is a centers, capital. Sorry, plural is used. Why is plural? Because there are two centers are there. So, centers of curvatures means, okay, centers of the sphere of which the lens is a part. Understand? Centers of the spheres of which the lens is a part. Okay, so that is the centers of curvature. Now, by joining these two centers, okay, we are drawing a line. Okay, then it is called the principal axis. What it is called? Principal axis it is called. Sure. So what is the principal axis? Principal axis is a line passing through the centers of curvature. Sure. Now, this is the axis of the lens, we can see. Okay. Now, center of the lens. What it is? Central point of a lens is called the, what it is? Optical center. What is there? Optical center. There what we see it as pole. Here it is optical center. What it is? Optical center. What is the optical center? Central point of the lens. How we can draw it? Okay, that is, this is the axis of the lens and this is the principal axis. Where the axis of the lens and the principal axis intersect, that is the optical center. Sure. Now, very important. Okay, other is the principal focus. Now, while telling about the principal focus, okay, now this ray of light which is falling on this lens, which is parallel to the principal axis, after refraction, okay, here the process is refraction. Okay, it will pass through a common point on the principal axis. Okay, that point is called the principal axis. Sure. Okay, so here it is of, we can say F2. Now, normally, now without drawing it, how we will see is, this normally it will take the half of this optical center and this. Okay, so if this is this much distance is there and its half will be taken for the, for what? Principal focus. So it is called the focal length. So what is the focal length? So optical center, then principal focus. That is, here also two principal focus are there. That is of F1 and F2. F1 and F2. Why? Because if the light is passing through this side, that is left hand side, okay, then the focus will be on the right hand side. Now, if the ray is falling to the lens from the right hand side, okay, then it will converge at a point on the left hand side. So here also you will get one. Again, here also same thing we have to do. Okay, the distance from the center of curvature to the optical center you have to take, and you have to take just half of it. Okay, there you will get the, what you will get, the principal focus you get. So the principal focus is always, okay, the half of the distance from the optical center to the center. Take care, because it is very important, especially to draw the ray diagram. Okay, now again, the distance from the optical center to the principal focus is called the focal length. So focal length. Okay, it is F1 and F2. Okay, and this is of a small letter F. And the centers of curvature is C1 and C2. Sure, all of you? These are the terms. Very important it is. Sure? Okay. Which are the terms? First is the centers of curvature. That is centers of the spheres of which the lens is a part. Okay. Like that in the case of the concave mirror, it is concave lens is also the same. Here. Now here one sphere is there and here one sphere is, so it is also having C1 and C2. Okay. Then this is the optical center. Sure. Then the half of this here it will come the principal focus, and here will come the principal focus. Sure, all of you? So this is the sum terms. Now the next is while telling about this is the convex lens and the concave lens. Now the concave lens is also called, convex lens is also called the convergence lens. What it is called? The convergence lens. Why it is called the convergence lens? Take care. Now the light, the ray of light, rays of light which fall on the lens after refraction converges at one point on the principal axis. That's why it converges, that's why it is called a convergence lens. Now at the same time, the cone, this is a convex and a concave. It is a concave. Now while telling you the concave lens, now the ray of light which fall on the concave lens, now it diverges. Look, it diverges. From a, that is, it is appears to be diverging from a common point on the principal axis. That point is called the principal focus. So it is called the divergence, because here what actually it is wrong. It is wrong. Sorry. This never it is like this. I think about the mirror. It is it is a diverge like this. It will come like this. Here it is diverge, it will come like this. So where the focus is, here the focus is. Sure. Now here the focus is real. Here the focus is real. And here the focus is virtual. Because here actually it is not joining here. It is appears to be diverged. It is appears to be diverged. Sure. Here it is converged. Actually converged. Here it is appears to be diverging from a common point on the plane. So it is in concave it is virtual. Here it is real. Take it. Now the next is of how to draw the ray diagram. Now I think that that we will go to the other class. One lecture we will keep to how to draw the ray diagrams. Now in this some the lens formula we will see. Before getting into the lens formula, let again the Cartesian coordinate system. Sign convention. Cartesian sign convention we studied the same thing. So there is no need to study it again. Here lens here. Sure. It is the origin. What is the origin is optical center is the origin. And here we are, object is normally placed here only. The object is placed here. This distance, objective distance. What is objective distance is U or V? It is U. Because yesterday I saw that object then image. So practically object then image. Alphabetically U then V. Like that you have to remember. From object we get an image. So what comes first? Object comes first. Like that. So object then image. In alphabetical order while telling about U then V. So object is related to U and the image is related to V. Correct? So here, where you will get here it is. Sure. So here you got the reward. You got the image here. So this is the image distance. That is, we can say that it is of understand? Now look here. This is of negative and this is of positive. Very important. If you are taking this side, it is negative and this side it is positive. Upside positive, down negative. Sure? That is what yesterday we studied. Same thing here applicable. Okay, where we are taking. So in that case, while telling about, now you know that in a convex lens, you know that, okay, in a convex lens you know that, okay, ray of light after reflection, where it is, here it is. So this side is, okay, so it is of positive. But in the case of the concave lens, okay, here it is a divergent and it is taking here. So it is taking to this side. So it is of negative. So focal length of a convex lens, okay, focal length of a convex lens is positive. Okay, then focal length of a concave lens is negative. So we can say if the focal length is given in positive, you can understand it is a convex lens, and if the focal length is given in negative, you can understand it is a concave lens. Good? Understand it well? Now, okay. Now, here the lens form. Very important. That is okay. Lens form. Okay. Now, in this lesson, okay, just a revision of the formula. Okay, what I'll tell you about. Okay, first about the mirror. Okay, first we see that R is equal to 2F. This is the spherical mirrors. For spherical mirrors, what it is? R is equal to 2F. Correct? Okay. Next, what we studied is mirror formula, that is 1 upon F is equal to 1 upon S V plus 1 upon U. What is V? Image distance. What is U? Object distance. Sure. Again we study that the magnification. Magnification M is equal to H dash upon H. H means the height of the image upon height of the object is equal to minus V upon U. Again V is related to the image. So related to the image must have, in the magnification, related to the image must have to come at numerator. Okay? Related to the image must have to come at a numerator. So it is of minus V upon U. Okay, take it. Now the lens formula. Now the lens formula, now the mirror formula. Spherical mirror formula is 1 upon F is equal to 1 upon V, okay, plus 1 upon U. Okay, now here only the difference is, okay, in the place of plus, here it is minus is there. Very simple to remember. That's why this also I told yesterday also, okay, even though you can here, you can write it as 1 upon V plus 1 upon U. Also you can write it as 1 upon U plus 1 upon V. But I mentioned that always you write in the form of 1 upon V plus 1 upon U. Why? Because it will help here also. So because here there is no confusion. Okay, that is always we use first image distance. Okay, that is V minus 1 upon U. This is the lens formula. Using this we will do the sums. Now the terms you know, F is of focal length, V is of image distance, U is of object distance. Sure? Okay, next is of magnification here also. The magnification M is equal to, what is here? Same, that is of H dash upon H. H dash upon H. What is H dash? H dash is the height of the image upon height of the object. Sure? So again, which is equal to, again here look, here the magnification is minus V upon U. No, here it is just V upon, that's all. There is no minus. Sure? Okay. Because normally here why there was this same only we can see that mostly here the same side it was formed. Here also mostly on the opposite side. Sometimes it is formed the same side. Okay. Anyway. Sure? So that is the magnification. And other one more term is there, that is the power. Okay. Power of the lens. Power. Now what is power of the lens while telling about? Okay, power means the degree of convergence we can say, or degree of divergence. That is power. Okay. That is degree of convergence. Okay, or we can say degree of divergence. Now look here, where the degree of convergence in the case of the convex lens, where the degree of divergence in the case of the convex lens. Okay, then okay, here this is the power of the lens. Now we can see that okay, here this power, okay, power means okay, here the mainly okay depends on the focal length f. Now actually here 1 upon f means it is a power only we are getting directly here. So what is the power means? Power of a lens P is equal to 1 upon f, that is focal length in meters. Very important. In meter. F in meter. Focal length must be represented in meter. That is the power. Understand? Okay. That is P is equal to 1 upon f and f must be in meter. Sure. So that this is the power. So what is power? Power is equal to 1 upon f. Okay. Now the unit of power. What is unit of power? We can say if it is of a upon, that is of a meter, that is okay, meter raised to minus 1. Okay, in SI system it is also represented by diopters. Correct? Diopters. Okay, diopters. Now diopter is represented by D. Sure. So the unit of power, okay, in here and all there is no such a okay, we can F, these are in the meter, etc. like that. Now here this new term, that's why it is especially it is told about. Okay, diopters means what is diopters? Okay, diopter is the what is diopters means a diopter is the unit of power. Okay, diopter is the unit of power. How will you define one diopter? What is the one diopter means? Okay, power of a lens is said to be 1 diopter if its focal length is of 1 meter. Okay, then okay, P is equal to, that is P is equal to what it is 1 upon FL focal length in 1 meter. Okay, sure, that is one only. Sure, so that is of the diopters. Sure, all of you. Okay, now so one more formula, P is equal to 1 upon F. F in क्या है? Very important, it must be in meter. So, and the other is of now when n number of lenses are, now you know that, okay, normally in microscope, okay, telescope, etc. Okay, we use n number of lenses. Then what will be the resultant power of that instrument? Here we will say that P is equal to P1 plus P2 plus P3 plus etc. plus Pn. N number of okay lenses are. That is, we can say that is of 1 upon F1 plus 1 upon F2 plus 1 upon F3 plus etc. plus 1 upon Fn. Here F1, F2, F3 etc. are the focal length. Sure, all of you? Okay, these are the main formula. Sure, all of you? I hope all of you understand these steps. Today we studied about the refraction by the spherical lenses. Okay, in that. Okay. Yes. Okay. What you have to do is you have to take the screenshot of this and study all these formula. This is okay. This formula, all the formula is of this lesson is there on the board. Okay. Spherical mirrors, R, radius of curvature. Okay. 2f. Correct. Then 1 upon f is equal to 1 upon v plus 1 upon u. Okay, m is equal to h dash upon h is equal to minus v upon u. V is the important. V is the image distance. What v is the image distance? What is u? U is the object distance. Lens formula 1 upon f is equal to 1 upon v minus. Here you have to take care. You understand that in mirror it is plus and in lens it is minus. Okay. Then is m is equal to h dash upon h and other is of v upon u. Okay. So power of the lens 1 upon f. And one term I forgot to tell, that is of even here it's also the aperture. Okay, this aperture means now here that I am going to keep. Now this is, yes. Look here, this lens, the diameter of the lens, I will tell you about this. Okay, this much is there. Okay, then I am going to write this. Okay, actually a circle is formed. Correct? Okay, this is the, actually we can say the diameter, total diameter. Okay, this is called the, okay, aperture. It is called the aperture. Sure? Okay, same. Okay, there also we see the aperture. Okay, same here also. What is there? Okay, aperture of the lens. So this is the aperture. So what is the aperture means here? This much. Now this is diameter. So this much what is called the aperture. Sure? Don't understand? Okay. So okay, that term actually I forgot. Okay. Now here the diameter. Yes. Okay, diameter of the aperture means whatever here we are, look, this much is, I drawn here this, okay, now, okay, this is the what, diameter of the aperture, we can say. Okay, so here, one more thing, here it is P is equal to 1 upon F, correct? F is the focal length in meter. Now you say that, you just see that, okay, which lens will have the more power. For example, okay, one is having the focal length 50 centimeter, okay, other is having the focal length 5 centimeter. Now, which lens have the more power? Yes, whether it is 50 or 5? Yes, it is not 5. Okay, it is 5. Why it is 5? Because when the denominator becomes small, this 1 upon reciprocal become high. Okay, that is here in the first case 1 upon 50 and other case 1 upon 5. Among that, which is greater? This is greater. Why? Comparatively, numerator is same. Denominator, which denominator is smaller, that quantity will be higher. Sure. So that from this one more thing we can say. Now this F means it is almost the half of the radius of curvature, we can say. Almost, not exactly in this case. In the case of the mirror it is exactly, but here it is almost equal. So that okay, here we can say the radius of curvature of the sphere, understand, is small. Okay. The radius of curvature is small. Radius of curvature is small means the lens become thin. Okay, if the radius thin, okay, we can say that you will have the more power. Sure. Okay. Then the other thing is one more term I forgot to tell, that is of radii of curvature. Yes. Radii of curvature. That also I forgot to tell. Okay. So radii of curvature means now yesterday there we see that two spheres are there, correct? Two spheres are there. Now if two spheres means it is having the two radius R1 and R2. Correct? Okay. The radii of the spheres, what it is? Radii, it is the plural of radius. Radii of the spheres, okay, of which the radii of the spheres of which the lens is a part is called the radii of curvature. Sure? Understand radii of curvature? Is the radii of the spheres of which the lens is a part. Okay, I forget at that time. Okay, this radii of curvature because it will come later. So all of you got? So what is P? This one more. P is the reciprocal of the focal length. Like that also we can say. That is already there. Is the reciprocal of the focal length. Sure? Understand all of you? I hope all of you understand it. Okay. Again, if any doubt, okay, you can post in the comment box. And in this lesson, on separate session, okay, we will do next class for the ray diagram. Okay. Then this lesson will be completed. So I hope you understand it, you enjoyed it. Thank you very much. Okay, don't forget to like it, share it, and subscribe. Thank you.
17.